Hello students, welcome to Class 10 Science. Today we'll discuss the topic acids, bases and salts. All of you must be familiar with these three terms because these have already been introduced in your junior classes. Now, the moment we hear the word acid, what comes into our mind? Yes, definitely. You may think it is something that gives a burning sensation, which can burn something. At the same time, some of us may feel that it is something which tastes sour, like, say, lemon juice. Now, what about bases? How do we identify base? What is its taste? How does it feel when we touch it? Yes, you all know bases, when touched, give a soapy feel, and if tasted, they give a bitter taste. Say, for example, you touch, say, washing soda or baking soda, or you eat baking powder or bitter gourd, they all give a bitter taste. That is the taste of base. So, in a way, we can say that acids taste sour while bases taste bitter. Acids, when touched, give a burning sensation, bases, when touched, give a soapy feel. But do you think it is always possible to touch or taste such substances to identify them as acid and bases? Not at all. It is not at all advisable to do so. So, what can we do to identify acids and bases without tasting or touching them? Yes, these can be recognized by observing their effect on certain chemicals or natural substances called indicators. They are also called acid bases indicators or simply indicators. Now, I am sure you all are able to recognize these three indicators: turmeric, China rose, and litmus paper, about which we have already studied in our junior classes. And we have seen that in case of all these three indicators, the color of the solution changes, and this color change helps us to identify which substance is an acid and which is a base. And all these three are natural indicators. Apart from these three, there are certain other natural indicators which help in identifying acids and bases, not by change in color but by change in their smell. So we can categorize indicators this way: visual indicators, olfactory indicators, synthetic indicators, and universal indicator. Natural indicators. These are obtained from natural sources, basically plants. Let us start with turmeric, which is a visual indicator. If we drop a basic solution on turmeric paper, we observe that the yellow colored paper turns red. But if the same turmeric paper is treated with an acidic solution, there is no change in the color of turmeric. Thus, by visualizing the color change effect of turmeric paper, we can distinguish between an acid or a base. Another visual indicator is China rose, which helps in distinguishing between acid and base by changing the color of solution. China rose indicator can be prepared by putting a flower of China rose or hibiscus in warm water and keeping it there for some time. After this, the solution becomes an indicator. When tested with acid, this indicator gives a magenta color, and when tested with base, it gives a light green color. The next natural visual indicator is litmus paper, or simply litmus. Now, what is litmus and from where do we obtain it? Litmus is obtained from Lichen. I'm sure you all know what is lichen. Lichen is a symbiotic association between an algae and a fungi. Litmus is extracted from lichen and then it becomes an indicator. It may be used either in solution form or it can be converted into litmus paper, the way we made turmeric paper similarly. The natural color of litmus is purple. So in a neutral solution, we get a purple solution, purple color with litmus. But to make it red litmus, it is treated with sulfuric acid or hydrochloric acid, and to make it a blue litmus paper or blue litmus solution, it is treated with a small amount of base. Thus we get red and blue litmus solution or red and blue litmus paper. And how is it used as an indicator? You all know that acids turn blue litmus red while bases turn red litmus blue. Among natural indicators, there are some indicators which are olfactory. That means the substances which change their smell when mixed with an acid or a base. Such indicators are called olfactory indicators. The commonly used olfactory indicators are raw onion and vanilla extract. Onion loses its odor, smell, when treated with strong basic solution, while the smell remains as it is when treated with an acidic solution. The same happens with vanilla essence. If we add some dilute vanilla essence to a test tube containing, say, dilute hydrochloric acid and another test tube containing dilute sodium hydroxide solution, we find that the one containing sodium hydroxide solution loses the smell of the odor of vanilla essence. It is not detectable there. So the one in which the odor of vanilla essence vanishes is a basic solution. Synthetic indicators. These are the indicators which are synthesized in laboratory. That means the source from which we obtain is not natural. The commonly used synthetic indicators are methyl orange and phenolphthalein. Phenolphthalein is a colorless solution which turns pink when treated with base, while it remains colorless when treated with an acidic solution. Methyl orange, as the name suggests, is orange in color. When treated with basic solution, it turns yellow, while when treated with an acidic solution, the color turns red. All the indicators that we have discussed till now are those which help us to identify whether the given solution or sample is an acid or a base, but we do not know anything about their strength. Now here comes the universal indicator, which helps us not only to identify an acid and a base but also to identify how strong an acid or a base is. So in the next session, I'll take up the topic of universal indicator. Here is a small practice session based on the topic discussed today. Till we meet again, enjoy learning.